Okay, so thank you, DST. Thank you, Sajid and Akhilesh Sab, for giving me this opportunity. And today, I'm not going to talk about what work is being done in ARCI, but rather I'm going to talk the title what is given to me by Sajid, that battery technologies for tropical regions. So when we say tropical, then we have to worry about the temperature. So Indian summer, if you see the temperature range, especially in summer, it goes up to 48 to 50 degrees centigrade. You can see whole country is red, leaving Gauti and other places and Himalayan region. So most of the maybe 70 to 80% of the country is in very hot, and then all the accidents of two-wheelers especially, they're happening only in this kind of temperature regime. So what are the issues? If you look back, I don't see any fire accidents for three-wheelers, and I don't see even electric cars, but mostly is happening in two-wheelers. But the reason, what everyone can understand, is in India, next 3 to 5 years, the market is huge for two-wheelers, and then there are a lot of competition. So many companies are coming with various models, and the battery packs what are being made are coming from various people, different companies. We don't even know where from they're coming. Within the India, they make battery packs, and they import the cells from some companies in other countries, and they can get for any cost. For example, if you take in China, there may be 10 companies who are very trustable, like CATL, BYD and all. But there are more than 20, 30 companies who can just give throwaway price. So one has to find out what are the reasons behind this, and this is a cost competitiveness. That means my product should be cheaper so that my products will sell better. So that's why I don't worry about safety, and I compromise on the sell what I get from neighboring countries. And the second one is, at the same time, I can only sell my scooter when the range is bigger. So the range anxiety is solved by using the cells with NMC. That means you are getting cells of NMC cells, which have got high voltage, and then they're more prone for fires if you don't have the proper BMS, and you are getting for very low cost. That means the process to make the cells are compromised heavily. And in addition, you also have the BMS, where Dr. Bala and then previous speaker says that a lot of components to make BMS are all imported. So you make the BMS, and the person who knows a little bit electric engineering or electronics, they just make BMS, and the other guy just put it in parallel and series combination and attach and sell the pack. So this is the most dangerous part in this kind of two-wheeler scenario. There are companies whom I know also, they are very good companies, but the companies, one company I know in Hyderabad, they struggle to make battery management, thermal management system by using PCMs. There's phase control agents, PCMs, phase change materials. So they fill the battery pack with the phase change material, and when the temperature rises about 50 degrees or 60 degrees centigrade, that melts and absorbs. But still, if the temperature shoots higher and higher, even the PCM cannot sustain that. So we are getting such kind of very bad cells. And then you see, there are two regions of safety. One is, you can see the Delhi or Varanasi or many places, they have three-wheeler auto rickshaws, and I was there almost 15 days for my father rituals in Varanasi, and I used to travel only in this three-wheeler, and they are very happy with lead acid battery, because that guy afternoon after food, taking lunch, he will take some 3-4 hours of the break, and then he will put it for charging, and again late night he will run it. So I don't say lead acid batteries, because you have, apart from lead toxicity, you have a lot of problems with the abusing. Whenever you have the flyovers or whenever you have to cross the speed breakers, you need to start, and then you need to put more pressure on the battery in terms of current loading. Then so that's why in every 6 months that guy has to change the battery. But he doesn't mind doing that when I talk to those guys, because he gets a lot of money again back when he sells it, so that overall he's not really getting. Whereas if he wants to buy a lithium-ion battery auto rickshaw, then he has to spend, provided you show him the advantages of the lithium-ion battery, what is being used, and then in terms of the safety, in terms of driving range and the cost and so on. Of course, FAME is there where you get subsidy, but still they're not penetrating into the market. So three-wheeler are so far have not used. And of course, recently Mahindra has come with this Terojor, which uses LFP battery packs. They import from China, BYD, I think, and then they are using, and that is quite safe. Because again, my point is that as long as you are getting the batteries, even NMC, I'm not against NMC, provided you have the batteries or battery packs imported from the certified companies, you still don't need to worry much. But if you compromise on that, then you are going to have a big blow. That's what we're seeing around. And if you see the Tata Nexon is using LFP battery packs, and Toyota Prius, and that is there for 20 years, and then they have doubled the energy density by changing their form factor and so on, and then still it's the safest bet. If I have to buy a car, first electric hybrid, I will buy Toyota Prius because I know that I'm safe. And what is worrying is LFP or NMC battery packs in two-wheelers for the reasons what I told just now. So the people who are riding the scooters, even with the battery packs, what are being compromised. One other part, what is missing is the user who is running the scooter. He doesn't know how to deal with this. He thinks that is driving a combustion engine vehicle, and which doesn't have any, where you don't have problem of firing. I leave my diesel car in hot sun, and then evening it's okay, because, but if I do the same thing for battery pack, even with the best thermal management, I think is going to have problems. So temperature is the big problem, even at outside temperature, and if you don't have proper thermal management, then that is going to blow up. So what I suggest for the two-wheelers is that better not to charge up to 100%, because the moment you charge 100%, you're taking lithium from the cathode and giving to anode, and your resistance on the cathode side is increasing, and you have the resistive heating, that's Joule heating I square R, and it's going to heat up. And avoid deep discharges and reduce power consumption, avoid hard and fast drive, do the smooth drive, and avoid parking in the sunlight, because your sunlight keep adding temperature rather than cooling, and then your temperature, the moment, although your room temperature is 50, it doesn't cool down, so the inside temperature keeps increasing, and once it crosses 100 or so, then you have all these problems. So I'm going to show what are those problems. And don't charge your EV immediately after parking it, because just wait until it cools down. Give 1 hour time before you recharge that again, and avoid quick charging. Quick charging means you're drawing current very fast and you're heating the battery. Okay, so now, what these guys do, the cells, what every nook and corner, there tons of people, companies, startups, they make the battery packs with half knowledge, and then they get the cells which are compromised, and then they make the battery packs. So why these are on fire? Manufacturing defects, metallic particles, if they're compromised, if they don't have clean room, and then compromise in the process place itself, and thinning of the separator, which will punch the cathode and anode during your charging if you do overcharging. And compact designs, you want to put more number of cells into the same volume, in that you don't give enough ventilative space between the battery cells, and then that is going to have big problem, because your cells have to be physically separate to a distance, even with an insulator, so that the temperature doesn't move to other part, the cell. And improper cooling system, air or liquid cooling is the best, and phase change materials people are using. But in two-wheelers, the problem is that you don't have enough space, because the vehicle is too small, and the active cooling system like liquid cooling are not used. So to my knowledge, only the PCMs are being used, but that will work very well provided your cell is not faulty, but that's not happening. And low quality components, when you do this packing also, your pure quality electronics BMS, as I already mentioned, and poor plastic body parts. So increasing competition is driving the prices of batteries down, causing battery manufacturers to cut corners where they should not. And if you see the battery, why lithium-ion batteries are different from lead acid or nickel metal hydride or any primary cells what we know. And all the cells what we know are aqueous batteries. So you have only water-based electrolyte and which is not going to blow up. But in lithium-ion batteries, the electrolyte what you have is essentially ECDs, ethylene carbonate, diethylene carbonate, which are organic solvents, which are like petrol and diesel. If you have a little bit of hot spot and they just blow, they get evaporated, and if the temperature further rises, then it will blow and then it will like a bomb. So you have, and in addition, you have the electrolyte, essentially LiPF6, it's a fluorinated salt, and when you have the decomposition of electrolyte, you're also going to get the fluorocarbons or even hydrogen fluoride. And you have the cathodes, which are most dangerous part of that. That is, though they initiate the reactions for the blowing to happen. So lithium cobalt oxide, lithium nickel oxide, and nickel manganese cobalt, they're all layered oxides by structure, solid state structure, and then they are easy to give the oxygen when the temperature shoots around 300 or so. That means as the temperature keeps increasing, this electrode at the cathode decomposes and then gives the oxygen, and then that will catalyzes the burning and then it blows up. So that's the reason NMC, especially when you have cobalt, it likes to give the oxygen away. So this is one of the reasons NMC is not good if you don't have proper electronics. Otherwise, I don't mind driving NMC car like Tesla. And lithium iron phosphate, LiFePO4. While you use only iron for the cost, low cost product relevant India, but you don't have cobalt and you have phosphate, PO4, and phosphate network is so strong covalently, it doesn't allow the oxygen to escape. That means my flash point or firing temperature is much below, much higher than the NMC. That means at least 70 to 80 degrees centigrade, it is above that one, it doesn't fire, it doesn't release oxygen. And the graphite is in the anode part, which is carbon. And when all this is happening, graphite also will start burning, and then you have separator, which is a polymer. So all these parts, what I'm showing, they are all easy to burn the moment they see some temperature and the oxygen in the cell. So we are dealing with literally a kind of situation where it's very dangerous if you are not dealing with it properly. And you see this slide, the left side part of the slide, you see carefully if you can see this. I'm giving for each one, I'm giving the source also, so that I'm not doing by myself. It's all for last 1 week. I've been accumulating data and then seeing that what best I can do. So in the schematic illustration, you can see from the bottom, this is a cell. If you see the background of this left side, it's the cell where you have the cathode, graphite is the anode. Let me put my, I don't know whether I can put the, I cannot put the cursor because it's not in the full screen mode. So anyway, within this one, it shows a cell where I have a cathode where I'm showing my cursor, the red bar side, and the other side is the oxide cathode. So now what happens is when you overcharge, for example, temperature is one kind of failure. When you overcharge also, the lithium gets deposited and then dendritic grows and then it punches the membrane, what is the polymer membrane, what is the separator. And also it will start when the temperature rises, once that happens, short circuit, the temperature rises and you can see as the temperature rises, a lot of things keep happening, your Joule heating and SCI decomposition. So overheat. Then your electrolyte reaction with the lithiated carbon because the SCI is gone, so it starts reacting to carbon and further increasing the temperature in some gases. And oxygen released from the cathode by 150 degrees, oxygen comes from the cathode and this starts enhancing the reaction and electrolyte decomposition, you start getting some alkane gases like methane, ethane and all, and they all blow up and then finally you have the fire. So by 200 to 250 degrees centigrade, which is internally happening, that is going to fire. If you see the right hand side, people intentionally did the experiment with the NMC cathode and saw how much oxygen is released. So you can see that as the temperature rises, the peak on the right side shows how much oxygen is going, and around 250 to 300 degrees centigrade, you have the maximum oxygen coming, and then this oxygen is the dangerous one, what is helping it to blow up. So 3 types of consumer lithium-ion batteries with the format 18650 with different cathode materials were evaluated in this paper, Royal Society, just to show that what kind of reactions and what kind of consequences happen under control conditions they did it. So as they increase the temperature, the onset temperature of this is 195 while NMC is 170. That means it is much lesser temperature, it starts heating up, and smallest temperature increase during the thermal runaway is 210 only, while for NMC it is 500. That means your internal temperature is going up very fast, and lowest amount of produced gas is 50 millimole, while it is 150 millimole for NMC, and lowest percent of toxic gas is 4%, you have 13%. Of course, for NMC, why you go is 3.6 volts against 3.3 for LFP, so your driving range will increase. Now, within the LFP being very safe, what people have done, especially BYD has done, is they have changed the format itself, and they call it blade battery cells, where you have 96 centimeter, 96 centimeter and 9 centimeter and 1.3 centimeter thick. That means you have a thin blade kind of cell, but long one, as you can see here, and that has more surface area exposed to the air so that the heat dissipation will be faster, while LFP being a low, more safe one with a high flash point. So this is the one, the BYD is now, blade batteries are coming very famous, and you can see here, I took a photograph of this slide and then just put it, and these are three scenarios. NMC is the lithium-ion battery is there on the left side, and in the center is LFP conventional battery, and on the right side is the one, what is the blade battery, and they put a egg in a metal cup, and then they put on that one. You can see that it blows up NMC, NCM or NMC same, and is a normal one. Still, it is charred, but it is not burnt, and nothing happens to this blade battery. So this is the data what is taken from their BYD site itself. So now what happens is now BYD India has launched all electric MP V6 with 71 kilowatt hour blade pack, and then using LFP battery pack for their SUVs. So a little bit, this is my 12th slide. I'm 15th slide, 3 more slides. So if you see the chemistry of the materials, what are used in the batteries, this is the voltage on y-axis. The 0 is the 0, that is the lithium plus. That means versus lithium anode, what is the cathode I use so that I get maximum voltage? If I use lithium metal foil, which is 0, and if I use lithium iron phosphate, I get 3.2 volts. But what we do is, if you use lithium, it will blow up because lithium is very, very sensitive to moisture and air. So people use graphite, which is very close to lithium, only 0.5 only. So still you get 3.2 when you use LiPF6 with graphite, or NMC. NMC has got 3.5 to 3.6, so that also will give higher voltage and higher energy density. But you can see the red regions on the top and bottom. Anode side, you have the red region where you have already solid electrolyte layer is formed. And even for cathodes, as you go for the higher voltage, then you start seeing some SCI, even cathode, which doesn't happen for the conventional materials. So when you are in the white region, you are less dangerous. So you take LTO, for example, lithium titanate, which has got 1.5 volts versus lithium, and is very safe. That's why LTO batteries are very safe, because they are not falling into red region. Means there is no SCI layer formation, and then it's very robust, and temperature doesn't cause any problem, and lithium can go very fast, and very fast it can come, which means that instead of hours you can do in minutes. That's why they are used in fast charging hybrid vehicles or the public transport vehicles. In Tosa in Switzerland, they use LTO batteries. And when you use LTO as an anode, you can use cathode, even little bit dangerous NMC, because always the temperature and the problem start at the anode, which happens at the lower temperatures, while LTO is there, which doesn't care the temperature, so the temperature doesn't shoot. So LTO and NMC, which is giving 2.3 volts, that is the Toshiba's recent battery, and then these batteries are being used, planned to be used for the electric hybrids, what is proposing even in India. So this is the one what different formats. Now it is able to get 23 ampere hour energy density batteries of the Toyota's LTO battery with NMC, or if you want high power, you have low energy density but high power. So depending on whether you want a fast charging mild hybrid or the plug-in or the stronger hybrid, you can choose the LTO battery, but still it is very, very safe. So you also, so while you see this, whether I want to go for NMC, if you want to go for NMC, better you have better BMS and better thermal management. If you want to go for LFP, still you are little safe, as you can see in the tri-wheeler auto rickshaw. Even three-wheeler auto rickshaw, they don't have active cooling systems, but still it works. But apart from that, you have to see alternate energy battery chemistries. Sodium-ion battery, it is almost as good as LFP battery with no lithium, no burning of these things in the anode and cathode, and then it is safe. Of course, you have the alkaline, which is organic. And supercapacitor, which is only 2.7 volts, but it has very high power, and you can use it in hybrid mode, even for regenerative braking. And going down LTO battery, I already said, and nickel metal hydride battery pre-use, Toyota is using for 20 years, and they're keeping on. But even today, if you want to buy Toyota Prius, you're still going to buy only nickel metal hydride batteries, which are aqueous batteries, alkaline, and then very safe, and then they never blow. There are no incidents. And lithium sulfur batteries are also safe. Why? Because the sulfur is in the cathode side, and cathode doesn't have oxygen. Even lithium iron phosphate contains oxygen, and lithium nickel manganese oxide contains oxygen, but sulfur doesn't have oxygen. So there are no issues of burning of these ones like blowing in these lithium sulfur batteries. Only some challenge of polysulfide migration, which are being solved the problems, and now there is a Lighten has come up with battery cells. Even we are working, and then we're trying to abate and making some prototypes at ARCI, apart from Supercap and LFP and LTO. And very recently, there's a company startup from IIT Kanpur. They call Zinc Gel Battery, which they are planning to, which already the two-wheelers, and which is again the aqueous base and then very safe. So all these are going parallelly along with the solid state batteries. So what happened? Am I lost? Okay, fine. Now the last one, last slide. What Akhilesh Saab is asking, what kind of suggestions we may give. So right now, sir, I am giving as a scientist of DST. It is only my personal suggestion. So suggestions to minimize fire action, you cannot completely avoid, because your cells, what you are bringing, if they are faulty, you can't help. So at least the public should not get into problems, and failure analysis of battery packs have to be done. I told Sajid also, and then I put in our WhatsApp groups also. You don't know what is the reason why this is being failed. So you bring back some of the जो बचा है वो batteries को ले लो, and you call some of the battery packs which the company is using, and start reversing and see that what kind of batteries they are using and where from, what is the origin of this one, and then regulate or stop imports of unauthorized, not certified cells. I said other than 10 companies in China, there are other companies who are very third rated, and then if you for cost compromise, if you start importing, then you're going to do this. So used battery, and sometimes people ask, how do I know whether it's a used battery or not? Suppose already it is used for 1,000 cycles, and then we don't know how to check whether it's used or not. And that kind of procedures are to be developed, whether to stop this kind of compromised batteries, and stop incompetent companies to make battery packs. Even within India, don't allow any company to just like that make, because any electrical electronics, they start doing this one nowadays, and stop that one. That is the biggest danger, and you are going to defeat all your policy and mission of electric vehicle if you compromise with these kind of things. Allow only those few companies having enough battery and BMS expertise, like few of the big companies. And then these batteries only may be allowed for swapping, and battery swapping policy, what we are going to propose now, given to BIS, and that is a wonderful policy. What we should do is we should allow some 5 or 6 companies who are very well versed and then known with expertise for making battery packs, initially to start with next 1 or 2 or 3 years. Allow only these battery packs to go into the OEM electric vehicles. Now we are telling The swappable battery packs. You don't need to have a electric scooter with the battery pack. You just, without battery pack, you buy a electric scooter like you do. I have only 4 or 3 companies, Indian Gas, HP, and all gas cylinders. You don't have multiple gas cylinders, but I had 10 people who can supply the gas stoves. So you always have that regulator is made by the company with the gas stove. If you come with some other cheaper one, I don't even touch it because it's very safety is the issue. It may blow up. Same thing. You treat your battery like a cylinder and then make sure that only those guys make that. And then you make your OEM can make electric vehicle and then just put this battery, make it with the same slot. So something like that is my own idea. It may not be followed, but DST can take a call. Allow certified EV vehicle manufacturers without battery packs and let them use the certified battery packs. Like I said, the 5 or 6 company from above company. Very recent, just now, someone shared in our WhatsApp group, our EV WhatsApp group. A startup company, Matter, developed an active liquid cooling pack for 2-wheeler to avoid this kind of battery fires, which is also a welcome one, but within a small place, how you integrate with the electric vehicle and then what is the cost of the battery pack. Already the cost competitiveness is the problem why you are compromising. But the moment you have the liquid cooling one, are you really increasing the cost? But this is good. So all these things should let us think once again, the policymaker, that what are we going to decide on these policies? Otherwise, after even now, I recently bought Vola, MG Hector Plus. And then I was thinking, at least I go for a hybrid car, if not fully electric, because I don't know how to charge and we don't have swapping. But then I asked them, can you give the hybrid vehicle? Then they said that we have mild hybrid. Then my hybrid, where is the battery pack? He says that under the passenger seat, that battery pack is there. I told my wife said that I don't sit in that car because under her seat, that battery pack is there. She said that Ambi paisa dera equally for your EMI, so better you buy only diesel car. And I bought diesel car because though I am working on technology transfer, the LFP and all this, but still I'm worried about my family and then my life, and my son is still in second year BTech. So I have to wait before I buy an electric vehicle. Thank you so much for your attention. Bye.